Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering a question submitted by a student. I want to find a line that's tangent to this curve at x equals 1, and that's the basic thing we have to find, and then we have to find something else after that, but let's just start with the basics. So here's our function. Let's call that f of x. So f prime of x here, we're just using power rule, so it's going to be negative 1 over x squared plus 1 over, oh, not 1, 2 over x cubed. So that's just using power rule. If you want to get a better look at it, you can think of it x to the negative 1 minus x to the negative 2. And then you just use the power rule. The negative 1 comes in front and reduce the power to negative 2, and the negative 2 comes in front, and so on. Now at x equals 1, f prime of 1, that's going to be our slope of the tangent line. So I'll put an m there. That's going to be negative 1 plus 2. So that's going to be a positive 1. And f of 1, the original f of 1, is going to be 1 minus 1, which is going to be 0. So we know it's going to go through the point 1 comma 0, and it has to have a slope of 1. So y equals mx plus b. The slope is 1. Y equals x plus b. And you plug in 1, 0, so 0 equals 1 plus b. B is equal to negative 1. So the equation of the line, the tangent line, is y equals x minus 1. Now, where does it intersect f of x? Where does this intersect f of x? Well, you would just have to figure out the solution to this. We'd say 1 over x minus 1, minus 1 over x squared equals x minus 1. And then we'd have to do some work here. So we need a common denominator, so it's going to be x minus 1 over x squared equals x minus 1 over 1. So x squared has to equal 1. And so x is going to be plus or minus 1. We already have x is 1, 0, so the other point must be negative 1. And you plug negative 1 into here, you're going to get negative 1 minus a negative 1, I think. Let's see. Negative 1. See, it's going to be 1 over negative 1 minus 1 over 1. So it's negative 2, I guess. Negative 1, negative 2. Okay, so let's confirm all this by looking at the graph of the situation. And I'm just going to insert a graph here, which I did ahead of time. Now let's move the graph over a bit so that you can see things a little more clearly. So the red is the original function, f of x, and then the blue is the line f equal x equal y equals x minus 1. Remember that the scale here, this is -1 here, this is +1 here. So it's going through 1 comma 0, and it's going through -1, -2. You can see this is the other point of intersection. And so we have solved and verified the answer to the question. So this question is it's a fairly typical question for this part where we're finding the equation of the tangent line. It's a little unusual to be asked for the intersection here, and you can see we had to do some reasonably challenging algebra here to get the answer. And it's at x equals -1 is the other intersection, and the y value is at -2, and you can see that from the graph as well. So that's it for this one. I hope this was helpful to you, and I'll see you again next time. Bye-bye.